1 sec. All right, yeah, it's working, fabulous. I was worried about my mic there for a second. Good morning and welcome to Stream, where today we are reading OpenAI's Whisper paper. My name is Dr. Rachel Tapman, and my YouTube channel is for anyone who cares about language technology and other people. And before anyone comments on it, yes, this mug does not have a handle. It broke, but I just keep using it because it's, holds liquid. Yes, so this is the paper for the Whisper ASR system, which some of you might have heard about. It came out in, it's not on here, but I believe the 21st or the 22nd. This paper has not been published and has not been peer reviewed as far as I know. It is a preprint. Hi, Brett, and also Brett. 2 Bretts in the chat. It is a preprint. And yeah, we're gonna do as much of it as we can before I start losing focus and or my voice, which is usually the limiting factor here. And I've looked into the system a little bit. We talked about it on stream on Thursday, but I think, to be fair, talking about it, it's reasonable to first read what they've put out. Yeah, so OpenAI, if you aren't familiar with it, is I think they call themselves a limited profit organization, maybe. It's sort of like a privately funded think tank that my impression is, I don't actually have like all the details about their financials or anything, kind of started running out of money to be just a pure research thing. So they started doing some product offerings as well. So like they do Dolly, GPT-3, you've probably heard of them. Anyway, and again, I don't know that that's true. It just sort of, that's my vibe. And then the authors on this paper, I'm not super familiar with most of them. I know that Greg Brockman and Ilya Sutskever are both pretty high in the organization's leadership. Greg Brockman might be the CEO. You know what? This is findable. Let me search real quick. I think Christine McLeavey has left the field and is now working as a pianist. I may be wrong about that, but I think I remember hearing that somewhere. He's the CTO and co-founder of OpenAI. So, all right, let's hop in. Just some background. I always like to talk about institutional affiliations and like if I have a relationship with one of the researchers, I generally try to disclose that. If I haven't in the past, that has not been intentional, but when you're reviewing papers, for example, if it is not anonymous review, like if you share an institutional affiliation with one of the researchers or they're like your friend, you want to share that information so that people know that might possibly affect your review. And in some cases, you may actually not be able to review a paper if there might be a conflict of interest. So, yes, I'm pretty sure I heard that. So, yeah. Oop. Clicked on a citation. Back up we go. Scroll. All right. Let's hop into it. So, abstract. We study the capabilities of speech processing systems trained to simply predict large amounts of transcripts of audio on the internet. So it's going to be, multimodal model, sort of similar to, all the text to image and text to video stuff we've been seeing. When scaled to 680,000 hours of multilingual and multitask supervision, the resulting models generalize well to standard benchmarks and are often competitive with prior fully supervised results, but in a zero-shot transfer setting without the need for any fine-tuning. Oh, when people say that a system is competitive with, what they mean is they didn't get state-of-the-art. If you see that in a paper, that's what they mean. But usually it means that they did okay. When compared to humans, the models approach their accuracy and robustness. We are releasing models and inference code to serve as a foundation for further work on robust speech processing. Oh, they did release the model. All right, noted. Also, as we will... we'll consider this claim when we come to it. But all that I will say on the matter is that sometimes people in the ASR community treat human speech perception as a monolith, and it is very much not that. A big part of my dissertation work was on perceptual learnings for humans learning new dialects they hadn't been exposed to yet. And it is, in fact, quite convinced. Brett says, squalling is all you need for my mispronunciation of scaling. No. Hi, Apsuna. Welcome. All right. Let's hop on in. Introduction. And we may or may not read all of this all the way through, but I think it would be helpful at least to read the background in depth. And I will say, again, full disclosure, I stopped really keeping up with the ASR literature sort of like as a field when I finished my dissertation. So, and I still read papers in the field occasionally, but I wouldn't say that I'm like I don't have the background right now to review this paper and put it in the, sort of constellation of other recent papers to the same degree that I did a couple of years ago. So I would say that the last sort of year that I had that sort of level of knowledge for would have been like 2018. And obviously there's been some big differences there. In 2018, 2017 was sort of when the big end-to-end deep learning model started to become, top of leaderboards. There was a really lot of leaning into it. Microsoft had a big model that came out around then. I'm trying to remember the name. That's what that face is. I'm making a face as I'm trying to remember the name. Oh, I don't remember the name. Anyway, that big Microsoft model that some of y'all probably know. And then I think also there was a big Google model around that time. So progress in speech recognition has been energized by the development of unsupervised pre-training techniques exemplified by Wave2Vec 2.0, 2020. Sorry, Bavsky et al.? Bavsky, perhaps? A lot of these names I won't know how to say, and apologies. And if anyone does know, please feel free to pop it in the chat and I will correct myself. Since these methods learn directly from raw audio without the need for human labels, they can productively use large data sets of unlabeled speech and have quickly scaled up to 1 million hours of training data, far more than the 1,000 or so hours typical of academic supervised data sets. How many hours are in Switchboard? Let me change that. Switchboard is a good corpus that a lot of people have used that, actually it's getting a little older now, so probably not going to be hours of speech. Probably not going to be as relevant for much longer, because I want to say it was done in the 1990s. So Switchboard is 260 hours of speech. 1 million hours is a lot in that context, and it was all, finally transcribed by hand. These pre-trained audio encoders learn high-quality representations of speech, but because they are purely unsupervised, they lack an equivalently performant decoder mapping those representations to usable output, necessitating a fine-tuning stage in order to actually perform a task such as speech recognition. All right, so what they're saying basically is that with the sort of like vectorization approaches that people are using, you can create a vector space, a latent space, representations of these audio signals. But then if you want to translate that into speech, like transcription output, which is the output of automatic speech recognition is usually a transcription of speech. You need to have the second half of the system, right? So classic encoder, decoder sort of architecture, which you may be familiar with from like, the history of machine learning, or transformers were originally proposed as an encoder decoder structure as well. This unfortunately limits their usefulness and impact, as fine-tuning can still be a complex process requiring a skilled practitioner. There is additional risk with requiring fine-tuning. Machine learning methods are exceedingly adept at finding patterns within a training data set, which boost performance on held out data from the same data set. However, some of these patterns are brittle and spurious and don't generalize to other data sets in distribution. We might call this overfitting. In one particularly disturbing example, Radford 2021 documented a 9.2 increase in object classification accuracy when fine-tuning a computer vision model on the ImageNet dataset, without observing any improvement on average accuracy when classifying the same objects on 7 other natural image datasets. A model that achieves superhuman performance, in quotes, when trained on a dataset can still make many basic errors when evaluated on another, possibly precisely because it is exploiting these dataset-specific quirks that humans are oblivious to. They didn't say overfitting once in that paragraph. Wild. Anyway, they've just described overfitting. This suggests that while unsupervised pre-training has improved the quality of audio encoders dramatically, the lack of an equivalently high-quality pre-trained decoder combined with a recommended protocol of dataset-specific fine-tuning is a crucial weakness which limits their usefulness and robustness. So you can turn it into numbers, but you can't turn the numbers into text without doing a lot of hands-on work. The goal of a speech recognition system should be to work reliably, quote, out of the box, in a broad range of environments without requiring supervised fine-tuning of a decoder for every deployment distribution. Whoa, that's a claim. That is absolutely a claim. So they're saying that any speech recognition system, the goal of any speech recognition system is that it should work in a broad range of environments without having to do fine-tuning. That is very much ahistorical. A lot of speech recognition systems, if you're familiar with Nuance's Dragon Naturally Speaking, a little bit of a throwback. Nuance is owned by Microsoft now, by the way, if you're wondering why you haven't seen them lately. Their whole shtick is that it was a speaker-tuned model. So not only was it not expected to work in a wide variety of environments, it wasn't expected to work with a wide variety of voices, right? It was tuned to the individual speaker. So this sort of idea that every model should be able to handle open domain and every model should be able to handle a wide variety of inputs in a wide variety of situations is certainly a claim that they are making that I think that a lot of people in the field would not agree with. Sip of coffee. Moving on. Oh, also I will say that, OpenAI as a research organization is very much a deep learning, machine learning research organization that happens to work on text and audio and images and not, a group primarily working on language data that happens to use deep learning, which is, I think, an important distinction. As demonstrated by Narayanan et al. 2018. Ooh, is this the, let me pop down here. IEEE 2018 SLT towards domain-invariant speech recognition via large-scale training. Is this the Microsoft paper? One sec. I'm gonna do a quick check. Also, just as a side note while I'm doing this, it is historically, this is the Google paper. Which is the system? One sec, I'm trying to find the system name. Historically, at least, the vast majority of ASR research has been done by organizations that have a lot of money because it has basically always been expensive, right? So back in the day, I can't find the system name. Is it Waveform? It might be Waveform. Don't quote me on that. So back in the day, sort of the powerhouse of, ASR research were Bell Labs, right? Like a lot of the early work was done there. Or at DARPA Labs. So DARPA is a US defense research agency. I think it's like the Defense Advanced Research Products Agency projects. Anyway, they fund a lot of, they funded, I think probably still do, a lot of foundational research in things like the internet, which was originally called DARPANet. So yeah, ASR and sort of speech recognition in general has very deep ties, certainly in the United States, with the US government and then with corporations with deep pockets. So the advent of small researchers or small research groups unaffiliated with people who had supercomputers doing ASR research and being able to sort of lead the charge there that period in time was pretty short, and I think we've kind of moved out of it at this point, unfortunately. Brett says, so the goal is a cloud-deployed one-for-all model. All speech will be recognized by a single mega model. Sounds great for privacy. Yeah, and yeah. I'm not to be like too, what's the word I'm looking for, cynical, but like if you are a deep-pocketed company who's trying to develop a product, if you can create a product that is so expensive to build that nobody else can do it, and then that covers so many use cases that everyone will want to use it, then that is great for you, right? You have a walled garden, no one else can do what you can do, and people have to pay you to do it because it's cheaper for them. Even if it's expensive to access the API, it's less expensive than it is to train one of these models yourself. And I've talked about this a lot. My bias in language technology is always for smaller systems for specific use cases. And I would say that this ethos is sort of the absolute opposite of my personal ethos about language technology systems. Anyway, all of these systems. Speech recognition systems are pre-trained in a supervised fashion across many data sets domains, exhibit higher robustness, and generalize much more effectively to held out data sets than models trained on a single source. Which, I mean, that makes sense, right? The more representation of variety you have in the data set, the more your model will be able to handle more variety in the world, right? So there's this concept from sociolinguistics called the envelope of variation, which are sort of like the edges of extreme forms of the way that a particular type of language might be produced. And this is, you know, it's sort of similar. Distributions, right? Everything's distributions. Everything's in a vector space. These works achieve this by combining as many existing high-quality speech recognition datasets as possible. And I will say, for the majority of speech recognition datasets, you do still have to pay for access. Most of them are not available for free, with the big distinctions, the big sort of like standouts of LibreSpeech, which is free, you may be able to tell from the title, and Common Speech by Mozilla, and I think Koki also has some free data sets. That's Koqui, Koki. Yeah. However, there is still only a moderate amount of data easily available. Speech Stew, one word, mixes together 7 pre-existing data sets totaling 5,140 hours of supervision. While not insignificant, this is still tiny compared to the previously mentioned 1 million hours of unlabeled speech data utilized in Zhang et al. 2021. Recognizing the limiting size of existing high-quality supervised datasets, research efforts have created larger datasets for speech recognition. By relaxing the requirement of gold standard human-validated transcripts, Chen et al. And Galvez et al. Make use of sophisticated automated pipelines to scale weekly supervised speech recognition to 10,000 and 30,000 hours of noisier training data. Alexi says, how's Caldi doing? Good question. I kind of stopped using them. For reasons of philosophical disagreements, let me put it that way. Yeah, I don't know. I haven't been keeping up with Caldi. I'm sure it's still around, just not something I'm personally recommending right now. This trade-off between quality and quantity is often the right call, depending, right? Depending on your aims. But again, they are moving from this premise that the ideal model can handle, you know, any input in any environment, which again, that is an argument that they are making. So if you accept that argument, then it makes sense that having more worse data would be better. Although undisputed so far, Although understudied so far for speech recognition, recent work in computer vision has demonstrated that moving beyond gold standard crowdsourced datasets such as ImageNet to much larger but weakly supervised datasets significantly improves the robustness and generalization of models. It also introduces its own issues. Alexi says Caldi's in the enemy list. I'm just not recommending it, you know. Yet these new data sets are only a few times larger than the sum of existing high quality. You know, I could zoom in a little bit more. One sec, let me make it a little bit bigger for you. Yet these new data sets are only a few times larger than the sum of existing high quality data sets and still much smaller than prior unsupervised work. Yes, it is the labeling that makes it supervised. Labeling, it will shock you to find out, is in fact very expensive and not free. In this work, we close that gap, scaling weakly supervised speech recognition the next order of magnitude to 680,000 hours of labeled audio data. We call our approach Whisper. Okay, so their contribution in this paper is that they have created a large data set. We demonstrate models trained at this scale transfer well to existing data sets zero-shot, removing the need for any data specific fine-tuning to achieve high-quality results. Are those data sets in this data set? Because if they are, then that is not transfer learning. That is just regular learning. Question mark. In addition to scale, our work also focuses on broadening the scope of weakly supervised pre-training beyond English-only speech recognition to be both multilingual and multitask. Of the 680 hours of audio, 117,000 hours cover 96 other languages. This data set also includes 125,000 hours of X to English translation data. We find that for sufficiently large models, there is no drawback and even benefits to joint multilingual and multitask training. Multitask makes sense, right? That's been a thing in the zeitgeist for a while. Multilingual is interesting. Sorry, that's me thinking. That's me thinking in linguist and not saying anything, which is great viewing just to watch somebody think about something. I'm going to put a pin in this and read more and then have an opinion, maybe. Or maybe not, who knows? Our work suggests that simple scaling of weakly supervised pre-training has been underappreciated so far for speech recognition. We achieve these results without the need for the self-supervision or self-training techniques that have been a mainstay of recent large-scale speech recognition work. To serve as a foundation for further research on robust speech recognition, we release inference code and models at GitHub OpenAI Whisper. All right, interesting. It is an acronym, the name, or if an acronym or basis for the name is desired, WSPSR stands for Web Scale Supervised Pre-Training for Speech Recognition. WSPSR standing for Web Scale Supervised Pre-Training for Speech Recognition can be used. All right, data processing. Yes, so the big, what they are promising in this paper is a big data set and removing the self-supervision architecture that a lot of recent models have had. Also, that they can do multilingual and multitask stuff because they have such a big data set. All right, let's find out more about this data because that is, this is the core of their contribution. So how'd they get it and what's in there? Following the trend of recent work leveraging web-scale text from the internet for training machine learning systems, we take a minimalist approach to data pre-processing. In contrast to a lot of work on speech recognition, we train Whisper models to predict the raw text of transcripts without any significant standardization, relying on the expressiveness of sequence-to-sequence models to learn to map between utterances and their transcribed forms. All right, interesting. This simplifies the speech recognition pipeline since it removes the need for separate inverse text normalization step in order to produce naturalistic transcription. Interesting. So by removing normalization, I would guess that they're probably going to get more errors that are weird given the frequency of the words, right? We construct this data set from audio that is paired with transcripts on the internet. Okay, this results in a, sorry, that pause was me being like, Okay, that is insufficient information. Are these, captions? Are these transcriptions? Are these, human annotated transcriptions? Are these close transcriptions? Question mark. This results in a very diverse data set covering a broad distribution of audio from many different environments, recording setups, speakers, and languages. While diversity in audio quality can help to train a model to be robust, I agree, and I think that's great. Diversity in transcript quality is not similarly beneficial. You don't say. So basically what they're saying here is like, hey, if you have a lot of examples of different speech in different environments with different acoustic qualities that maps to the same set of transcriptions, that's great because you're going to see a lot of variety when your model is deployed if you're looking for this very general purpose model. But, if some of your transcriptions include and and things like that, and others don't, then that's unclear signal for your model, right? Or if some things include like tagged information about who's speaking, your model may just sort of hallucinate different people speaking different things in regular transcriptions because it's been given a lot of examples of that, even if that's not actually the case, even if that's not relevant given the audio input. Initial inspection showed a large amount of subpar transcripts in the raw data. To address this, we developed several automated filtering methods to improve transcript quality. Where did you get this data? Where is it from? Also, they are inconsistently capitalizing internet. Here it is capitalized, and here it is not. So, yeah, I would probably put that as just like a bullet point in a review. Yeah, so if you, I'm going to keep reading because maybe they do in fact have more information on where this audio comes from. Let's go on. Many transcripts on the internet are not actually, they're right next to each other. One of them's capitalized, one of them's not. Pick a style guide and stick with it. This is a very, I realize that this seems like a very nitpicky thing to be, grumpy about, but whether or not internet is capitalized is like a whole big thing. Gretchen McCullough, if you know her, she's a linguist who does a lot of content on the internet, has a whole big thing about that. So I'm more primed to look for that than other things. Many transcripts on the internet are not actually human generated, but the output of existing ASR systems. Recent research has shown that training on data sets of mixed human and machine generated data can significantly impair the performance of translation systems. Yes, it's almost as if you need high quality data to train a high quality system. In order to avoid learning transcript ease, we develop many heuristics to detect and remove machine generated transcripts from the training data. So I think that could be a useful contribution as well to detect ASR transcriptions in data. Many existing ASR systems output only a limited subset of written language, which removes or normalizes away aspects that are difficult to predict from only audio signals, such as complex punctuation. There is no punctuation in speech. Formatting white spaces such as paragraphs, or stylistic aspects such as capitalization. None of these are in speech. These are not features of speech. These are readability features that are produced post hoc to capture some elements of intonational information. Alexi says, maybe I don't want to know where they got their data from. No, I really do. I really do want to know. Yeah, all uppercase or all lowercase transcript is very unlikely to be human generated. I don't actually think that that is the case. The reason that I say that is a lot of captions for television, like live television captioning, those are done by humans, and those are often all uppercase. Well, many ASR systems, so again, citation needed. Well, many ASR systems include some level of inverse text normalization, it is often simple or rule-based and still detectable from other unhandled aspects, such as never including commas. I mean, if you were doing a close transcription of speech as a linguist, you would not use commas either. They are making a lot of assumptions about transcription practices and what is and isn't human-like here that, again, big ol' citation needed. Alexi says there's a whole Wikipedia article on conventions for the capitalization of internet. Yeah, it's a big thing. And it's fine. I don't mind one or the other, but you should be consistent. I've talked about this before on various places on the internet. Language identification, or in this case, audio language detectors, are extremely noisy, especially for rarer languages. Rare as in they occur less often in training data. Yep. We also use an audio language detector, which was created by fine-tuning a prototype model trained on a prototype version of the dataset on Vox Lingua 107 to ensure that the spoken language matches the language of the transcript according to CLD2. Oh, so they're doing Lang ID and then audio language detection. I mean, I guess at scale, you're going to lose some data, but my worry here is that what you would be losing would be non-standard variants, right? So just as an example, right, the type of Mandarin used in news broadcasts is going to be very different from the way, even that like within Mandarin, that language would be used in various, you know, different regions and places, because the news broadcast version is hyper standardized, right? Or I think, and if any of y'all know this, please feel free to correct me, but I believe that news broadcasts in the Arabic speaking world tend to be in not a regional variation, but something that's closer to modern standard Arabic, which is a bit of a lingua franca that I don't think anyone really speaks as their home dialect. So I would worry that you would end up with a situation where you got like a lot of examples of, you know, hyper formal language use that is not representative of the language communities that would be trying to use the system day to day. But I mean, they've fully said that in this paper that data quality is not something that they care about. If the two do not match, we don't include the audio transcript pair as a speech recognition training example in the dataset. We make an exception if the transcript language is English and add these pairs to the dataset as X to English speech translation training examples instead. We use fuzzy deduping of transcript text to reduce the amount of duplication and automatically generated content in the training data set. Okay, so they're not automatically generating content in the training set. So if the audio language detector doesn't detect something as English, it's treated as an X to English translation task. One does wonder how much English was detected as not English using this audio detector, right? English has a lot of variety in it, right? Like Singaporean English, very unlike Scottish English, very unlike Southern US English, very unlike New Zealand English, all native English speaking communities with a lot of variation in how they produce language. Anyway, moving on. We break audio files into 30-second segments paired with a subset of the transcript that occurs within the time segment. We train on all audio, including segments where there is no speech, though with subsampled probability, and use those segments as training data for the voice activity detection. So there's no held out test data, is what I'm getting from that. For an additional filtering pass, after training an initial model, we aggregated information about its error rate on training data sources and performed manual inspection of those data sources, sorting by a combination of both high error rate and data source size in order to identify and remove low quality ones efficiently. I think this is great, right? Like if your model is consistently messing up on something and there's a lot of that in your data set, absolutely worthwhile to go look at it. The inspection showed a large amount of only partially transcribed or poorly aligned / misaligned transcripts, as well as remaining low quality machine generated captions that filtering heuristics did not detect. So I think this is fine. It's a good approach. No issues with that. To avoid contamination, we performed deduplication at the transcript level between the training data set and the evaluation data set. We thought were at higher risk of overlap, namely TED Liam 3. Wait, is this a data set? So is this a data set of data sets? Question mark. Alexi says, made me remember when I learned that actual English speakers speak nothing like the people on the English class audio tapes. Brett, give a smiley at that. Brett M, sorry, not Brett C. Brett C is a different Brett. Yes, unfortunately. Language, as it is used day to day, tends to be a lot more messy and complex than what is presented to you in a pedagogical setting. Okay. So they did do, so this was a question I had earlier about whether or not they removed the evaluation data that they tested on that they said was out of fold with the training data. And they did do some deduplication, but there was a possibility that that data had been included in the first place. TEDLIUM 3, twice as much data and corpus repartition for experiments on speaker adaptation in SpecCom, SPECOM 2018. And I'm just going to quickly pop open this one and see what their data sources were, because this is the first information that we have on what sort of data might be in this data set. Brett C also did a smiley face C. All right, so this is from, right. Noted. I tried to drag a tab from one type of window to another, and that in fact does not work. But let me just quickly look through here. TED conferences is where, so they include TED conferences. Yes, okay. So there might have been TED Talks in the training data. So far, that is the only information that we have, besides that it was on the internet. All right, up we go, up we go, up we go. Oh, that's it. That's all the information we have on the data set. All right, well, it was on the internet. It had transcriptions, some of which might have been machine made, some of which may have been human made. I don't know. They provided no information on that, and some of which may, and some of the audio data may have included TED Talks. Oh, and I should point out that they are only looking at data sets that they only looked at some of the evaluation data sets to check for overlap, but not all of them. So there very well could have been leakage in that way. But of course we don't know, because we don't have any information about the data, any other information about the data. And they talk about the model. And actually, I'm just gonna go down and see if there's anything in the appendixes that I missed. Because I did do some, okay, so these are all of the data sets that they were evaluating on. These are not the data sets that they were training on. That's different. Deticia says, are you on Mac? Tab moving hasn't been working for me either. No, I film on Windows, but I tried to move something between Firefox and Edge, and as it turns out, you cannot actually do that. I don't know, maybe you can on a Mac. I've used Macs for work. They're just not my favorite. I've been so deep in Windows and Linux land for so long that it's hard for me to, you know, use something else at this point. All right. So this again is their performance on other data sets. And there's a bunch of evaluation. Data set scaling. Oh, this must be in the conclusions as well, I'm guessing. Yes, analysis and ablations. Text normalization. Right. limitations in future work, decoding strategies, increased training data, stunning fine-tuning, blah, 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 add additional objectives. Now I'm into the citation, scrolling. I'm just trying to see if there's any more information on the data set that they used. Evaluation data sets. Nope. Long form English only data sets. These are still that they are evaluating on. Nope. Oh, they use Coral. That's nice. Coral is the corpus of regional African American English out of the University of Oregon. Tyler Kendall's the first author. It's a great data set, and they did a lot of work on it, and it is extremely high quality. So if you were looking for a data set to work on, to use, the Coral data set is a really good one. And it came out in 2021. They've been working on it for, God, years. It was so much work. Anyway, good data set, good researchers. I'd recommend their work. Common Voice, compared models and where they got those. Facebook, Microsoft, SpeechBrain. I'm pretty sure this is Google. Text standardization. Okay, so they did some changing of the transcriptions. I'll go back up and look at that in a second, because I guess that's additional information. Alexi says, get the mouse with the infinite scroll wheel feature. I don't know, I kind of like scrolling. Multilingual transcription, again, this is the data sets they are evaluating on, not data sets that they include. All right, training data statistics. So this is the information they have on the training data. For the... Okay, so they have the multilingual speech recognition, translation, and the dataset components, which is 17% multilingual speech recognition, 18% translation. And remember that the translation data is based on audio identification, automated audio identification of the language, and they only include it if the transcription is in English. And I'm just sort of like looking at some of these languages. 2 examples from Malagasy, 72 for Albanian, 74 of Haitian Creole, 79 of Mongolian. So those are for the translation, which may very well include mislabeled English data. And then for the multilingual speech recognition, is this? Yeah, this is logarithmic. So the top 5 are Chinese, German, Spanish, Russian, and French. And then Portuguese, Korean, Japanese, Turkish, Polish, Italian, Swedish, Dutch, Catalan, Finnish, Indonesian. We have not yet come to an African language. Arabic is spoken in Africa. You know, to be fair, French is spoken in Africa. Ukrainian, Vietnamese, Hebrew, Greek, Danish, Malay, Hungarian, Romanian, Norwegian, Thai, Czech, Tamil, Urdu. Sorry, I'm looking for an African language. Croatian, Slovak, Bulgarian, Tagalog, Welsh, Lithuanian, Latvian, Azerbaijani, Estonian, Slovenian, Serbian, Persian, Basque, Icelandic, Macedonian, Armenian, Kazakh, Hindi, Bosnian. Sorry, those are 2 different languages. Galician, Albanian, Sinhala, Swahili. Here we go, way down at the bottom. Alexi says it actually makes scrolling more fun. You can click, unclick the wheel. Also nice for fidgeting. That's cool. I will say that I have a, I'm not going to pick it up because I don't want to point a laser at my web camera, mouse that I got for $10 used, and a keyboard I got for 10. No, the mouse was 5, the keyboard was 10, because I don't tend to treat my peripherals super nicely, and I also don't care that much. I'm not a fancy person, if you could not tell by the fact that I'm using a mug with a broken handle, because it still works. Afrikaans. I'm pretty sure Kannada is Indian language. Haitian Creole is a language of the African diaspora, but yeah, so very strong focus on European languages, including some like very small minority European languages. Not that that's wrong. I'm not. It's just like there's a lot of Eurocentrism here, and there's also a fair amount of coverage of languages of Southeast Asia in particular. But yeah, a lot of missing things. In particular, I only see 2 on my quick scroll through. Oh, Sudanese. Okay, so that's 3. I only see 3 languages that you could, 4 if you're going to count French, that you could argue would be African. I see no indigenous languages of South America. I see no indigenous languages of North America. So yeah, very skewed representation there. All right. And also, a lot of these languages are fairly closely related to each other. A lot of Germanic, at least in terms of the ones that have like a lot of representation. Anyway, accent variety seems to be missing. Yeah, almost seems like that would be relevant information, huh? Almost it seems as if everybody who speaks French does not speak the same French. Or perhaps there might be multiple very important distinctions about which Portuguese variety you're listening to, huh? Yeah, so weird. Interesting. Rachel, you seem like a little bit saucy about this. Yeah, if your main contribution is that like, hey, we have this large data set, and it is a language data set, and you are doing automatic speech recognition, which, as we know, is to this day, even with very large systems, very sensitive to differences between dialects and varieties, maybe you should report that information. Would it be more work? Yeah. Yeah, that's why nobody else has done it. It's very expensive and it takes a lot of work. For those of you who aren't super familiar with my work, my dissertation was on ASR systems and human perceptual adaptation, but also taking ASR systems and, improving both accuracy on out of training dialects, but also creating the same sort of errors that a human would have, because I think that is I wouldn't say that they were explicitly cognitive models or models of cognition, but a lot of my work was trying to do like, hey, if there are errors, they should not be surprising that they are errors and what the errors are, if that makes sense. Alexi says, would be interesting to see the ratio between the data amount and the world population of specific speakers. Well, I can tell you right now that they had 860,000 hours and 117,000 of those were not in English. So I'll tell you right now, there's a big skew towards English, which is just sort of the way, oh wait, does this have, can I? No. Sometimes PDFs on Edge will have a table of contexts that you can use to hop between sections, but it looks like this one didn't. Also, let's look at these text transformations real quick, because that is other information that we have about the data set, which again, the authors say is one of the main contributions of this paper, although of course it is not actually available. ASR is automatic speech recognition. Sorry, I don't know if I said that. Yeah, so it's this sort of, sometimes people will call it speech to text or STT, but automatic speech recognition doesn't necessarily imply that you have to go to text. Usually it does, but you can go as a component of other systems. All right, so since Whisper may output any UTF string rather than a restricted set of graphemes, that's good since you're doing a lot of languages that cannot be represented using ASCII. The rules for text standardization need to be more intricate and comprehensive than those defined on e.g. ASCII characters. We perform the following steps to normalize English text in different styles to a standardized form, which is the best attempt to penalize only when a word error is caused by actually mistranscribing a word and not by formatting or punctuation differences, which is reasonable. Again, most close transcriptions by linguists have no punctuation. Yes, population value means languages like New Zealand Maori are often not in use, or often aren't worked on by people working on ASR systems, I assume is what you mean there. Yeah. This is something we're going to talk about on Thursday, but I would say it's good when you are thinking about relationships between speaker populations and the necessity of language technology for that population, not just to look at ROM numbers, but also, to what degree would this improve access for the community? Is this a community that wants language technology? A lot of there's a lot of cultural diversity in the world, right? And some language communities may actively not want their language written down, which is something that, you know, linguists should also take into consideration. The field has definitely gotten better than it used to be. And also, languages with very small speaker communities may need language technology more in order to, you know, maintain the persistence of their language into the future. So they may have a greater need for language technology than larger speaker communities potentially. So yeah, I think it's good. I think it is helpful to know about the rough populations of speaker communities, particularly for languages that are majority languages of a country. But I also think that it's important not to just make our decisions based on number of people who use a thing. Because if there's a lot of existing tools in a sort of a medium-sized language and a very small language has a language speaker community that has, or language user community, they don't have to necessarily be speaking the language, that has a really strong desire and need for language technology tools. And I think it makes more sense to focus like research grants and things like that towards that community. So anyway. Alexi says Edge. Yeah, so I use Edge for my streams because I don't use it for anything else. But the PDF viewer, pretty good. You can also draw on it. Wait, I could be drawing on this the whole time. Does that show up on stream? It sure does. Well, noted. Yeah. Brett says, it's writing interactive literature. Sorry, off topic, but I thought people would be interested. Oh, I think I might have missed something. Let me see. If you posted a link, I can't see it. Yeah, anyway, that's just sort of my aside. We'll talk about that later. So what do? They removed any phrases between matching brackets, so in square brackets, which I'm assuming is to try and capture things by like HTML weirdness, like links and stuff. Remove any phrases between matching parentheses, that's a choice. Remove any of the following words, and in British English, that would include things like er, as well, which is a non-rhotic representation of so that's quite the set that you picked there. That's not super representative of all the English interjections. Also, these sort of disfluencies or floor holding markers do include information. So in general, for language systems, I would not recommend removing them unless it was absolutely necessary. Remove white space characters that come before an apostrophe. Convert standard or informal contracted forms of English into the original form. Like which ones? Like is y'all now you all? Because that's not what that means. That is a distinct word. That is a lexical item. Again, would love more information on this. I realize I am like very frustrated by this, but this paper for me is very frustrating because this is their main contribution, is this data set, and they don't have enough information provided for me to know whether or not it's actually useful. And we know that it's not all very high quality transcriptions, and their argument is that it's okay based on these evaluation data that we're not going to go into a whole bunch of depth. You can read it if you want to. But like, what language data was it trained on? Because you know, were any language communities excluded from it? Were those language communities then included in the evaluation data set? Because if they weren't, then you just wouldn't know about that blind spot, right? So, yeah. Brett says, cool drawing skills. Ooh, I posted a line. Yeah. I'm not the best visual artist, I would say. Not my medium, really. Removed a comma between digits. Remove periods not followed by numbers. So this means that things like, oh wait, I can draw. So like in the US, right, 1 million would be like this. Yeah? In Europe, 1 million would be like this. Please enjoy my circles. Right, so like I believe in French, that is the convention is to use periods between digits to indicate, you know, blocks of 1,000 instead of commas. Now that I've said that, one sec. French, 1,000,000 periods. I just want to double check some things. I kind of get, yeah. So like in French, which we know they said that they said that they have French language data in this data set. So these ones would be kept, these ones would be removed. That's wild. Why would you make that choice? Like, thank you for telling us about it, but wow, the US centrism on here. Brett says, our main contribution is our data set. It's okay for our data to be bad. I mean, like, that's what their argument is, right? Like, it doesn't matter if it's low quality or there's issues with it because there's so much of it, which, I don't know that I agree with that. I mean, I'd want to do my own evaluation of this system. And like, maybe that's what we'll do next, right? We'll do an evaluation of this Whisper system because the models are available. What do I think about modern mixed people languages such as Surzic? I'm not super familiar with this language variety. I don't think I know much about it. Let me look into it. Refers to a range of mixed sociolects of Ukrainian and Russian language used in certain regions of the Ukraine and neighboring regions such as Russia and Moldova. There's no unifying set of characteristics. Oh, okay, so it's like a dialect cline like you have in Italy, Italy going up into the Alps. Yeah, perfectly normal thing for language to do. Very common. Yeah. Brett says, or even in speeches in places like Montreal, or Montréal, if you're being super Frenchy about it, where people switch back and forth between French and English without missing a beat. Yeah, so if that's in the same sort of language span, that would be called code switching, and in a multilingual community, very common. And also, for those of you in the US, most language communities are multilingual. A strongly monolingual language community is a little bit of like an anomaly, both sort of globally and also throughout history, right? And it usually is the result of a imperial power that has a vested interest in maintaining linguistic homogeneity, and as a result has depressed the use of different languages, right? So like, my great-grandma spoke Cornish, which is a Celtic language that she learned from her adopted parents, and no longer used, right? Considered a dead language, due in no small part to linguistic imperialism by the English, right? Hence, you know, I'm speaking English. I'm not speaking Gaelic or Gallic or Cornish or Welsh or any of the other languages that my ancestors spoke because of the, you know, pervasive influence of linguistic imperialism. So yes, weird both historically and globally. Most language communities are multilingual. And the fact that NLP tends to assume that you're just going to get really long spans in a specific language and only that language is, again, not really reflective of human language use and the human language experience. Yeah, so like switching back, sentence to sentence, or even word to word, right? Like the classic greeting in Montreal is like hello, bonjour, right? Yeah, so code switching is the term for that. It can be individual words, it can be whole spans, and again, very common in multilingual communities, which is to say, most of them. All right. Remove symbols as well as, oh, I'm still drawing. Remove symbols as well as diacritics from the text where symbols. What? Sorry, that. Again, please remember my PhD is in linguistics. Let's just go through here, and I'm just going to quickly highlight some of the languages that have diacritics. German, diacritics. Spanish, diacritics. French, diacritics. Portuguese, diacritics. Turkish diacritics, Polish diacritics, Italian diacritics, Swedish diacritics, Dutch diacritics. You did what? Not a choice I would have made. Noted. Okay, well, is this only on the English output? Okay, so maybe this is only on the English output, which would be good, but also there are English words with diacritics, right? Never remove diacritics. Don't do it. They're there for a reason. Anyway, where the symbols are as the characters within the Unicode category, starting with M, S, or P. Okay, so they're only doing fit for some of it, except period, percent, and currency symbols that may be detected in the next step. Where, oh, no, they removed all diacritics. Okay, and the symbols that they removed are everything from the Unicode category, starting M, S, or P, right? Yeah. Brett says, bonjour, hi. Yeah. A good tip for you if you are not great with French, do not reply bonjour. They will assume you want to speak in French. FYI. Detect any numeric expressions of numbers and currencies and replace the form using Arabic numerals, e.g. 10,000. This is a wild choice. So usually in speech transcription, you go the other direction. Right? So you would take this $10000, which is, by the way, a perfectly valid way to express that span of text, with the written thing $10,000, T-N space THOUSAND space DULLARS. Convert British spellings into American spellings. Okay, so this is a okay, so if there's British spellings in the transcriptions, we can assume that there is language data produced by British English speakers, yeah? In which case, I would say that the British spelling is probably, because again, these are not closed transcriptions, the correct transcription for that speaker. I would not have done this. Remove remaining symbols that are not part of any numeric expression. What? Okay, so there's an additional removing symbol set where they don't tell you what those symbols are. Okay. Replace any successive white space characters with a space. Okay, so if you have like space, 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 it would just be replaced with space. That one's fine. A different language-specific set of transformations would be needed to equivalently normalize non-English text, but due to our lack of linguistic knowledge to build such normalizers for all languages, we resort to following basic standardization for non-English text. Okay, so they're not removing all the diacritics from all of the non-English text, hopefully. Remove any phrases between matching brackets. Again, I don't understand this, like what I would do here is I would remove HTML text, right? It is designed to be computer readable. It is computer detectable. You can just get rid of it. People do use parentheticals, and since they're working under the assumption that adding punctuation is desired in transcripts, I would not be removing it in the evaluation data. Make the text lowercase, sorry, is one of the things that they said. German is your second most used language. Capitalization is grammatical in German. It identifies lexical items. Not a choice I would have made. In fact, the existence of that feature in German is what I canonically use as an example of why you don't want to remove capitalization. Also, there's inconsistent capitalization in these bullet points. Replace any successive white case characters with a space. Additionally, we put a space between every letter for the languages that do not use spaces to separate words. Oh, you're just... Okay. Well, that's quite the approach to word identification. Noted. Cool. I guess this makes sense if you were just trying to look at the character error rate. Again, not a choice I would have made, but they just said about how they don't have linguistic knowledge, which I would say is apparent based on this pre-processing. Whew. God, if an undergrad came to me, if a graduate student came to me with this project and they told me this was their pre-processing steps, I would have a lengthy discussion with them. And the first part of the discussion is, why the hell are you trying to shove so many languages into your basket if you don't have the knowledge to evaluate the data in those languages? My first thing would have been like, you don't even need this much data, use other data and have a narrower scope for your system. But that's the second thing I would say. But what do I know? I don't have $10 million worth of compute or however much it cost. We note that the above is an imperfect solution. Well, it's good. It's good they know it's bad. And it would sometimes produce unintended and unexpected outputs. We do not claim that the text formatting result is more correct in any measure. Rather, the procedures above are designed to better distinguish between innocuous differences in wording and genuine mistranscriptions. Python code for the standardization procedures above is available as part of our code and model receipts to facilitate future iterations and improvements on text standardization. Yeah, don't use their code. I mean, maybe use it as a jumping off point, but that is fascinating. Like, I get how you'd get here, and it would be not having the linguistics background, and, you know, they straight up say that they don't, so, I mean, good for them. Yeah, I'm gonna highlight this, because I know I can highlight things now. Yeah, I would say that this is sort of like a good summary of what happened so far in this data set description. I can see why they didn't try to get this published in InterSpeech. Or maybe they did and they didn't accept it, but... or maybe they did and they just haven't announced it yet. Who knows? But yeah, I can't imagine a whole lot of people who have a big depth of knowledge in the ASR space being delighted with these pre-processing steps or the complete opacity about what's actually in the data set. That is, in fact, extremely important. And the reason that Common Speech, which they use, right, like they're like, hey, this is high quality data that we can use for evaluation. Common Voice. The reason that Common Voice was, you know, put together in the first place was to have a large data set where there was detailed demographic data about users included, because that's important in a linguistic context, in a speech context. And also to make it freely available, right? LibreSpeech and Common Voice are both available for free. I don't know about this one. I'm not super familiar with it. I don't know about this one. It's a subset of Common Voice. So yeah, so this one would also be available. These, last I checked, are very much not available. You have to pay the LDC for it. Wall Street Journal, you gotta pay LCC. Coral is freely available. Chime, I don't know. I'm not familiar with that data set. But a lot of these data sets you straight up have to pay for access to. Because it's, well, I mean, speech data sets are both expensive to put together and expensive to host. And that's how the LDC continues to be around, because LDC is the Linguistics Data Consortium. They've been around for a while because people pay them. All right, well. That's an odd choice. They use a subset of examples for the human transcription data. Okay, so they're having humans do it. So they were like, we have to subsample this. We cannot do everybody. They use the RevAI podcast transcription benchmark. These are almost certainly Rev is a company that does transcription of usually like videos and stuff. And I believe that they have an option that's fully automated. They have an option that is automated with a human pass, and then they have an option that is just a human pass. And I believe that a lot of their transcribers are sort of like crowdsourced. So I don't know whether or not this is actually a transcription, human transcription data set. There are multiple cases where a significant portion of the audio and labels did not match, mostly in the parts introducing the sponsors. I would guess this is because people just didn't know how to spell company names, or if it's automatic, it was out of vocabulary, and they selected episodes that did not have that error. data from the Late Show with Video Colbert with closed caption data. So closed caption data is done by humans and corrected with manual inspection, but I believe it is usually done by humans real time, which is obviously going to have more errors than things done by humans carefully. All right, well, so these are the data sets that they were using to compare to, but that's all the information we have about the data that they used. So they did this post-processing transcription to it, and it might have included TED stuff, TED Talks, but they weren't sure, and they searched for some potential overlap. Yep. And then they just used an off-the-shelf architecture transformer. So I'm not going to talk too much about the model architecture because it's, again, they weren't saying that that was a contribution, except that they didn't use the self-supervision. And basically what they're claiming here is that with a big enough data set, you don't need to do any of the model-specific stuff. You don't need to have high-quality data. You can just keep shoving stuff in there and it'll kind of work, is their idea. And if you're wondering why the self-attention in the self-attention in the transformer is different from the self-supervision or self-training techniques, I'm not super familiar with these, so I don't know. Yep. That's just regular transformer. And then, okay, so they're using the spectrogram instead of long-Mel spectrogram. Okay, so they're using a spectrogram instead of any other sort of acoustic or spectral features that you might use. MFCCs is an acoustic feature that used to be pretty popular in speech transcription. I don't know, or ASR research. I don't know as much, if it is as much anymore. What says, anytime I try to speak in French, they detect I'm terrible and respond in English. Andre says, Czech in Slavics is the Slavic language with the most diacritics used, is what that looks like. Brett says, so they fall into the trap of we are AI experts, we don't need to be or employ domain experts. I mean, yeah. And I guess like that's sort of where the field is now, right? Like if you just have enough data and enough money, you can spend the data and money on compute on a model that's big enough to do as well as you could with less data if you had more domain expertise. And I don't know whether or not that's worth it, right? Clearly they think it is. And, you know, they did the OpenAI classic publication by press release, by which I mean, this is not a published paper, this is a preprint. The reason everybody knows about it is because they did a big press release. We're like, we have this new model, it's so good. Which, I mean, in the abstract, we can quickly look at some of the evaluation metrics. In the abstract, they were talking about how it was comparable or competitive, right? So so looking at, you know, just sort of other models, they did like, okay, but certainly not better than. And the point they have here is that at, you know, the average RER, results reported in word error mate for both models after applying our text normalizer. So I guess this would be like normalized error rate. I don't know what the R stands for there. Usually you report things in word error rate. What is this RER? Sorry. That must be some sort of benchmarking that they were doing. Sorry, I'm just scrolling looking for RER to pop out of the text. Detailed comparison of robustness on robustness error rate? Libra speech, but rather than data sets, 55%. All right, so basically what they want you to get here is that their numbers are lower than the wave to VEC numbers. Also, the human evaluation here, I believe, is one of the authors. Yes, which I would say is a pretty clear conflict of interest, and you probably should have paid somebody else to do it. Despite matching or outperforming a human on Libra speech dev clean, supervised Libra speech models make roughly twice as many errors as a human on other data sets, demonstrating their brittleness and lack of robustness. The estimated robustness frontier of zero-shot whisper models, however, includes the 95% confidence interval for this particular human. So what they're saying is that they do sort of like as good as this human who has a vested interest in making sure that it looks like this model is very good. Which, like, I don't think it's wrong for researchers to do annotation. In fact, I think it's very important that researchers do annotation. I do think that having a single human who, again, has a vested interest in making this model look as good as possible as your human example is maybe not the result that I would expect to produce the greatest ecological validity. Put it that way. Oh, thank you. James says RER's improvement, just the difference between the two previous columns. Thank you. That is very helpful. Oh, it's a rate. Gotcha. Okay. Because I was like, that is not... I was doing some subtraction. And listen, I know sometimes I can make simple math errors, but 10 minus 4 is not 60, but it's as a rate, so they've multiplied everything by 100. Or I guess as a percentage of the wave to VEC error rate. Interesting. Not something I have seen a lot of in ASR papers, but then I haven't super been reading them recently, and it's been a couple years since I was super active in this space, so maybe this is the common way of doing it. All right. Here's the multilingual. Hours of transcribed audio, and then word error rate. So the more data you have for language, the better you do, with the pretty strong outlier of Chinese, which does not surprise me. And I think KO is Korean. I don't remember the ISO code HE off the top of my head. So the sort of the outliers here are that the word error rate is worse, even though there's a lot of data for for Chinese and Korean, these 2 points here. Wait, one sec, I can draw. This is great. I'm a huge fan of this. And it is better than expected for Spanish, Italian, and Portuguese, given the amount of training data, which is not surprising because all of those languages are extremely closely related to each other. So you get more information from Italian. You get more information about Italian from Spanish than you do about Korean from Chinese, because those are much less closely related languages. And I am not going to get into arguments about the language topology and relatedness of languages of Eastern Asia, because that is fraught space. And I don't know enough or feel strongly enough to have big opinions there. Yeah, so this is just the speech recognition. And then here's the correlation between so this is like, very good linear relationship, which is not surprising. This is a little bit more surprising. Correlation of pre-training supervision amount with downstream translation performance. The amount of pre-training translation data for a given language is only moderately predictive of Whisper zero-shot performance on that language. So looking at these, so these would be for blue, So word error rate, lower is better. For blue, I think higher is better. One sec. Yes. Also, just as a note, blue should only be used as corpus level measurements. And I'm assuming that that's what they're doing here and treating each of their languages as a corpus. So the languages that do significantly better with less data are, again, Portuguese, Dutch, I think, is DE, FR is French, CA, probably Catalan, if I had to guess. Sverige, so that's going to be Swedish. And the ones that did like way worse than expected, well, I mean, it's not a super strong relationship, but that have a lot of data and lower goodness, Chinese, Japanese, Korean, CI, ISO language code, CY, sorry. I'm looking it up. It's Welsh. Oh, right. Yeah. ES is Spanish. So you have sort of like a band here of Romance languages. I believe RO is Romanian, which also a Romance language. You may be able to guess from the name. Yeah, so it looks like there's a sort of European, non-European language split here. I guess, you know, Romance Germanic language, non-Romance Germanic language split here, which again makes sense because there's not going to be a whole lot of, you know, ability to learn about other languages based on the presence of a lot of related languages, right? Like Welsh is Celtic. Celtic languages are very unlike Germanic languages, if any of you have tried to learn one. Let me just look. I think it might also be the only Celtic language, which makes sense. So this is for the translation, right? So Welsh was third. Russian, Spanish, Hindi. Hindi is actually more closely related to English than Welsh by a wide margin. French, German, Portuguese, Arabic, Turkish, Polish, Italian, Urdu. I'm just quickly scrolling and seeing if there are any other Maori. Oh, they didn't have it in the multilingual though, did they? Maori? I don't remember seeing it. So they only have that in translation. And again, we don't know how many of these are the result of just straight up language errors. And it could be that a lot of things that were tagged as Welsh are just Welsh people speaking English. And is that Basque also, Basque is a language isolate, which means we don't know what other languages are related to it. It's very, the counting system of Basque in particular, very unlike other languages that it is close to. So I'm still scanning looking for any other, oh, so there are some more African languages down here. Amharic, Somali, Lingala, maybe. I'm not entirely sure where that's spoken. Yes, so that is the only Welsh language. It's the only member of its family in this data set. So you're not going to get cross-lingual sort of, not even cross-pollination, but information, right? So like if you know, like Latin, right? Like I think it's just like Pisces means fish in Latin, and you know, a lot of the Romance languages have words that are very like fish or very like Pisces for fish. English doesn't because it comes from a Germanic root. So if you have a lot of words that come from the same root, they're going to look sort of similar and they're going to sound sort of similar enough that you can get information between them. Yep. Khadija says, have I added African languages to the base training data? This is not my data set. I'm trying to, sorry, I'm trying to imagine myself releasing this data set and the just like roasting the absolute, right? Like my degree's in linguistics. I wouldn't be able to work again in the field after releasing a data set like this. Yeah, it would be a bad time for me given my disciplinary heritage. So not my data set. But part of the reason that I'm looking for African languages is that, you know, African languages are very diverse. There's a lot of language families in Africa. I mean, language like started in Africa. There's been a lot more time for it to like get interesting there. And all languages are interesting. All languages are beautiful. I'm not saying that any language is better than any other language, but like in terms of linguistic diversity, Africa is a very high level. Also tend to be very underrepresented in data sets. And also, to be perfectly frank, the field. I would love to see more African researchers working on their languages, and very happy to see, you know, the people who are doing that. So like deep learning in Daba is a big group that people have been, you know, coming together. I know there's a lot of folks, particularly in Nigeria, a lot of folks working on Amharic and the languages of Ethiopia, South African linguists. So lots of good people doing good work, but particularly, you know, a lot of these multilingual data sets tend to be like a tour of Europe with some stops in Asia. And this is, you know, a great example of that. Yeah. Andre says the biggest group is the Indo-European languages family. Maybe a number of speakers overall. But yes, a lot of languages are Indo-European. So all the Germanic languages, all the Romance languages, some languages of India, not all, not most, in fact, but some languages of India also come from that language family. So English is Germanic, Indo-European. I think there's another like subfamily in there. I don't remember. Khadija says, I'm from Senegal. Ah, fabulous. Welcome to the stream. Yeah, I would love to see you have a long, successful career working on language technology. Yeah. And then translation. So this is so this is on translation, and this is on just straight up speech recognition. So as a reminder, those are different data sets, I believe, because I don't think if something was in the recognition set, it also went into the translation set. So even with non-overlapping data, we still see the same pattern. I don't know if you heard a sort of laser sound, but that was my dog. He had some opinions. Bless him. Anyway, and then here's their sort of performance. So the red stars are their model, and they're sort of showing that their model does, I mean, honestly worse in a quiet environment than a lot of other models. But as the environment gets noisier and noisier, so white noise is just going to be like, shh, right? It's random noise across the spectrum, where pub noise is probably just going to be like a cocktail party, clinking, clinking, clinking. And they're saying that like, hey, we're more robust to noise, which makes sense because it's a noisy data set. So I imagine that it's been trained with a lot of very noisy data. Both there is noise in the data set and also individual data points have noise in them, from their discussion. Very limited discussion of their data set. We're using a pre-training model to fine-tune on our local language. Ah, fabulous. Yeah, I hope you're having a lot of success. Aryan language is European in India. Came from the Ukraine. I think the origins of Indo-European are so long ago that very little can be said about it for sure. So Proto-Indo-European is sort of or PIE is sort of the reconstructed form, and the only sort of information that we have about that is through words that are robustly cognates across language families that are part of Indo-European. So like, we're pretty sure that Proto-Indo-European had a word for bear, for example, so it probably existed within the range of bears at the time that it split off into different language families. But yes, there's also a lot of people who say a lot of just like wild, unsubstantiated things about the history of languages. So I would be, I would be quizzical of your sources, even academic sources, when it comes to very, very ancient stuff. All right, and then this is transcription. Yeah, they did really well on this TED video set. I'm not entirely familiar with the contents of these other data sets. This one I'm guessing is mostly on like language technology stuff, because I believe this is the podcast data set. Brett says, I don't find the white noise and pub noise evaluations particularly compelling if they want to claim any noisy environment, not all noise is created equal. Yeah, that's a great point. And also, like, car noise is not white noise. I think it's closer to brown or pink noise because it has a lot more lower frequency stuff. So like if you wanted an ASR system to work reliably in a car while the car was running, you would need to have, or any vehicle, right? It doesn't have to necessarily be a car, but like the noise environment of a car, the noise environment of a train, the noise environment of a bus, the noise environment of an airplane, airplanes are a little bit closer to actual white noise, are going to vary substantially. Yep. Yeah, I wonder what is in this data set. And the other thing to think about with this evaluation is that they did not guarantee that they did not have the evaluation data in the training set. They looked for some of it where they thought it was likely. Also, another thing that really jumps out to me here is that this is very, very high compared to everything else. And this is, if you remember, the corpus of regional African American language, which means that if you are looking at African American language users in the United States, so this is a language form, their model does bad and it does worse than it does on any other single task. Also true for this other commercial model, also true for this commercial model. And true, but this green model that they won't tell you which one it is actually does better than any of the other ones on African American language in particular. So yeah, so like what I mentioned with, it's important to know the dialects that are in your model. I think based on this, it's fairly safe to say that African American language is probably underrepresented compared to other language varieties in their model, and certainly underrepresented compared to this company B that they won't tell us what it is. So, Ravi says, ancient, is a linguist a mix of anthropologist? Great question. So, they are related fields. So anthropology is the study of human cultures. Linguistics is the study of human languages. There are people who do both linguistics and anthropology. Often, in order to study a culture, you have to speak the language of the people who are in that culture. So generally, when people are, I will also say, stepping back, that there is a long history of colonialism, of racialized violence, of straight up eugenics in both anthropology and linguistics, which has to some degree been addressed in those fields, but know that particularly when you're looking historically at these fields, that is a big part of it. So just, to be very, very forthright and upright about that, it's important to know about the history of the fields. So linguistic anthropology, definitely a thing. They are not subfields of each other, and anthropology and linguistics have sort of diverged more and more since, I would say, the early 20th century. Especially around the time when you have a lot more focus on the computational aspects of linguistics. So linguistics as a field sort of drifted from being very close to anthropology to being very close to computer science and sort of the early days of computer science, to currently sitting sort of like at the nexus of a lot of fields. So if you have a linguistics degree, you've probably had training in formal logic. You've probably had training in like fundamentals of computation, even if they weren't necessarily given that name. You've probably had training some in anthropology. You've probably had training in at least one language other than English. Most linguistics programs require that you have that, and a lot of them also require that you have training like to speak and read in a language that is non-Indo-European as well. You've probably had training in linguistic-specific disciplines like phonology, syntax, formal semantics. You've probably had training in psychology to some degree. You've probably had training in statistics. You've probably had training in acoustics. So I did a lot of work in graduate and undergraduate on phonetics, which is the science of speech sounds. You may have had you'll certainly have some anatomy training. You'll certainly have some like close listening training to be able to listen to speech sounds and transcribe them. So it's a field that encompasses a lot of subfields that are pretty different from each other. Sociology, you will probably have had like a basic introduction to sociology and how it affects language usage. So where linguistics faculties sit in universities varies widely. Oh, and philosophy, particularly in Europe, you're probably also going to get training in like semiotics and that sort of stuff. Not as much in the US. We don't tend to be in the semiotic space quite as much. So, do we know the language spoken by the Neanderthal? No, we don't have conclusive evidence about whether or not they used language at all. In fact, when you get into like that sort of deep history thing, it is very hard to make claims, particularly about language, because language is ephemeral. The most we can say is that, you know, based on the anatomical structures that were present, speech would or would not have been possible for a specific individual. Whether or not they use speech is hard to say. And also a lot of the anatomical modifications that we've made to use speech also make it possible to like suckle. So I'm not saying that other species don't suckle. Obviously they do. But it's sort of like a modification of sort of those types of fine-grained motor coordination. Swallowing is fascinating, by the way. Also, it can get messed up. Great, because you have to have the timing right, so you don't like choke and die. And it's a little bit easier for kids because of the way their vocal anatomy is. But there are diseases where, particularly as the result of like brain damage, you can lose the ability to get that fine-grained timing that you need to swallow without choking. And it's horrifying. It's really scary. So for people who have that sort of disability, thick water is one of the things that will be used so that they can drink without dying. Anyway, if you've heard about thick water, that's one of the reasons why it was created. Anyway, big ol' rant. It is interdisciplinary, yes. We don't have fine-tuning code. Oh, code for fine-tuning the model. Yeah. I think they may have some of their code available. No, it's zero shot. They wouldn't have any fine-tuning code. Nope. Yeah, you may have to roll your own, unfortunately, or code your own. All right, let's look at this. I'm going to read this section on human performance because I love to suffer, and then the data set scaling, and I think that's about as much as I have. And maybe the section on text normalization. I think that'll be about as much as I have capacity for today, because I'm getting off topic. And this one. All right, let's go. Comparison with human performance. Because of ambiguous or indistinct speech, as well as labeling errors, there are different levels of irreducible error in each data set. You fix them. And with word error rate metrics from the ASR systems alone, it is difficult to make sense of how much room for improvement exists in each dataset. Okay, so basically it's saying they don't know where ceiling is, but they assume it exists. Andre says, Aryans equal to Indo-Iranian, not Ukrainian. Yeah, I'm not super familiar with that branch of the family. To quantify how close Whisper's performance is to human performance, we selected 25 recordings from the Kincaid 46 dataset and used 5 services to obtain transcripts produced by professional transcribers. Okay, so this makes sense. They're not just using that one transcription from one of the authors, the first author. One of the first authors. I think there's 2 first authors. Among which one provides... oh, so this is discussing about the savers. Among which one provides computer-assisted transcription and the other 4 are entirely human transcribed. I'm guessing that this might be... They probably wouldn't use Google service, so that might be... I think DeepGram and Rev both offer some human transcription services as well. The audio selection covers various recording conditions, such as scripted and unscripted broadcast telephone and VoIP calls and meetings. So this is, nope, this is the analysis of their model. This is not actually information about their training data. Ugh. Figure 7 shows the distribution of per example word error rates and aggregate word error rates across the 25 recordings, where the computer-assisted service has the lowest aggregate word error rate that is 1.15 percentage points behind whispers. So this is where there's a human correcting a transcript, and the pure human performance is only a fraction of a percentage point better than whispers. Okay, so the computer-assisted transcription is worse, and the pure human is better. These results indicate that Whisper's English ASR performance is not perfect, but very close to human level accuracy. Okay, so this is what this figure is, where this is the Whisper system, this first one, the rest are other systems. This is the human transcription here. So lower is better, and they're saying that Whisper is like sort of in here where the humans are. I will say that I noticed that these two have big outliers, as does this one and these two, which may be pulling them up a bit. Like obviously this is, maybe not obviously, this is representing the interquartile range, but it is noticeable to me, like that just jumped out at me, especially given how tight the performance of this system is otherwise. Yeah, interesting. So what I was going to say about human performance and human transcription, right, is that humans transcribing audio is not human perception of speech, right? We use it as a proxy that is easy to measure, but human perception of speech is situational, and that situation encompasses both the listener's previous experience of all speech, the listener's previous experience with a particular person they're listening to, and the environment they're in. So that's the social environment, that's the physical environment, right? So I can change your perception of the exact same speech sound by changing the objects in your physical environment. I'm not talking about acoustics. I'm talking about like replacing one stuffed animal with another stuffed animal, right? We are embodied cognitors, if you will, and human speech perception is not a monolith. It's not a monolith across individuals. It's not a monolith within individuals, and it's not a monolith for, across speakers. So I think that this comes up a lot in the ASR literature, and it bothers me every time. Treating, a small sample of transcribers who may or may not be familiar with the language varieties that you are having them transcribe, who may or may not be familiar with the subject matter, who may or may not be familiar with the specific voice they are hearing, is not a good reflection of actual human language perception. It is specific task-based, and particularly with crowdsourced workers, you don't know the language backgrounds of the people who are doing this transcription. So it is, a low bar. Let me put it that way. It is a very low bar. And if I had a human that I talked to regularly who misunderstood me as often as commercial ASR systems, I would assume either A, that they were being, they weren't paying attention to me, which I would find kind of rude, or that they may have some sort of either audio processing or, language understanding, disability, or they may have hearing problems, right? So your experience of language perception and people who are perceiving you, like those of you who tune into my YouTube stream a lot, you have an easier time understanding me than a streamer that you are just listening to for the first time, even though I talk kind of quickly, because you have so much more exposure to my voice. So yes, there are a lot of things, a lot of subtle things that affect language perception in humans, and transcription, especially commercial transcription, where usually error rate is a little bit less important than just like turning things out really quickly. And also the person who is transcribing may or may not be familiar with the language variety you are asking them to transcribe is a proxy and a lossy proxy. So making claims of human level performance based on that proxy always makes me a little antsy. Anyway. Yeah. Brett says, when researchers claim superhuman, are they talking about the word error rate of transcription? How much off might the measure actually be? What's a better metric? That is a great question. So I think, right, it's the easy measurement, and I completely understand that. But what I used for, my, experiments when I was doing this in graduate school is I used very controlled situations with human listeners. So I gave them a voice that they had all never heard before in a language variety they'd never heard before. And then the machine learning system had the same thing, right? It had been trained on one language variety. I was giving it a new language variety and a new speaker that it had never encountered before. And when all of those things were held equal, I mean, obviously it wasn't a big ASR system. It was like a machine learning model that considered some features. The model performed worse, but it also performed human-like in that its expectations were not met in a very specific way that I was messing with it. But that was expensive and it took a really long time, and getting participants was also very difficult. So I understand why people don't do that, particularly because I didn't have money to pay crowd workers. And also I was specifically looking at people from a specific language variety background, which meant that I couldn't use, most folks. So yeah. Alexi says, oh, the gray needle brainstorm multi-stable perception. Yeah, absolutely. So like a audio illusion, right? Where you can have the same audio output that sounds two ways and you can sort of like push yourself to one or the other. There was another one with Yanni and Laurel that happened a while ago where it was the same, acoustic thing, but depending on whether or not you'd primed yourself to think about Yanni or Laurel, you would hear one or the other. I would say those sorts of illusions are very rare, but certainly errors in perception are not uncommon, but yeah. Yeah, so usually when people talk about superhuman, they are talking about the word error rate of a transcription service these days. Used to be it was of close human transcriptions. And I would say probably overall the quality of transcriptions in the ASR literature, I mean, this paper is a great example, have gone down over time as there's been more focus on scale because it's just like, it's expensive. It's expensive to get humans to do stuff. And it should be. So yeah. Anyway, so we talked about that, and then data set scaling. So here they're saying like, hey, is it important that the data set is one of the largest ever created in supervised speech recognition? So they trained a series of models on subsampled versions of the data set, which are 0.5%, 1%, 2%, 4%, and 8% of the full data set size, and could compare their performance with the same model size trained on the whole data set. Early stopping based on validation loss was used to select model checkpoints for each data set size. Very reasonable. Especially with that smaller data set size, I imagine they reached saturation a little bit faster. Evaluation was performed on an exponential moving average estimate of the parameters using a smoothing rate of 0.49 to help reduce the effect of the learning rate not fully decaying to 0, blah, 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 blah. Not super important. Can you imagine if they had this level of detail about all of the data set decisions that they made? Anyway. All increases in dataset size resulted in improvement performance on all tasks, although we see significant variability in improvement rates across tasks and sizes, which I imagine is dependent on the subset of the data that was selected. Performance improves rapidly on English speech recognition from 30,000 to 13,000 hours, and then slows down noticeably between 13,000 and 54,000 hours. Using the full data set, which corresponds to another 12.5 times increase in size results in only a further 1 point drop in word or error rate. So this section here basically says that the benefits of their large data set only really see significant improvements when you, well, I mean, obviously more goes up, right? But that you stop seeing a good, what's it called? you start seeing diminishing returns at about 13,000 hours, which is, one sec, I'm doing some quick maths in another tab. About 24% of the data set. Noted. Brett says, the cloud is a factory, your AI is a human, your computer's on fire. Alexi says, if I want to make ASR for a rare language, in my case, Yakushan, apologies if I'm saying that incorrectly, what is the best practical way? That is a great question. So I would probably, I would make sure that you have the highest quality transcriptions you can. The sort of the historical way, which tends to work better with smaller data sets, is to have 2 stages in the model. So one is to take the model and create so like they were talking about with the encoder part of it, and create an acoustic model, and then to have a second part of the system which is based on a language model. And the reasons that those are split apart is that the language model can be based on just text, and of course the acoustic model has to be based on text and well, has to be based on speech, right? And then you need to know the relationship between the two to do the full system training. But language modeling originally, and the fact that you can have it just based on text, was used to rank the output of acoustic models to pick the most likely one, given a corpus of information about your target language. So particularly if you do have more information, access to more text than you do audio, my recommendation would be to use that sort of older approach where you train your acoustic and language model separately and then, you know, combine them into a single system to get you the sort of the most bang for your buck if you have a limited data set size. Also, much cheaper, much cheaper, much smaller. Yeah, so that would be my general recommendation in that set. Yeah. This mirrors the diminishing returns observed with model size scaling for English speech recognition and could similarly be explained by saturation effects when approaching human level performance. Citation needed. Improvements in word error rate follow a power law trend for multilingual speech recognition. Yeah, I'm less interested in this because I don't actually think it's probably super helpful for particularly the minority languages. Sort of similar to multi-BERT, right? Like, it's just less good if you're one of the minority languages. There's a paper on a team who's building a chatbot for Vietnamese, and they found that fast text was just the simplest way and training raw fast and text embeddings from scratch was much easier than trying to fine-tune multi-BERT because they just did not have the training data to do it. Yeah, you're very welcome, Alexi. Best of luck. Yep. The general trend across tasks of diminishing returns when moving from 54,000 hours to our full dataset size of 68,000 hours could suggest that the current best Whisper models are undertrained relative to dataset size, and performance could be further improved by a combination of longer training and larger models. It could also suggest we are nearing the end of performance improvements from dataset size, scaling for speech recognition, or that the information in that data set is so noisy that you would need more high quality data to increase the amount of information that is learnable. Further analysis is needed to characterize scaling laws for speech recognition in order to decide between these explanations. Lexi says, what about training on a similar language? Yucatan is from Turkic family. Maybe. I guess it depends on how similar the languages are, right? I would guess you're probably going to have a little bit more luck using very related languages, particularly if their phonemic inventory is very similar for the acoustic modeling. So the phonemic inventory means, do they have the same language sounds? Also, if you are trying to go from, you know, sound to potential, you know, set of symbols, do they have the same writing system, which is also going to be an issue, because I know that there's a lot of variety in what writing systems languages in the Turkic family use. So if you have a language that is very related, that has the same set of sounds and the same writing system, go for it. It might get a little bit weird. And also, I mean, I would say, what is it that you care about. Why are you building this, right? Like, what specific use case do you have for this model? And based on the use case for that model, does it make sense to build something general purpose, or do you want to build something that's very domain specific? Because the more domain specific it is, the less data you're going to need, right? So like, if I'm trying to identify digits from speech, I need a much smaller data set than if I'm trying to, let's say, transcribe court proceedings, where I'm going to need to have a much bigger data set that's more representative of the type of language you'd see in court proceedings. Does that make sense? Yep. Alexi said, writing system is going to be an issue. Yep. You could use an intermediary system that represents the underlying phonetic structure of the language, right? So ARPABET is kind of commonly used for English, which is a representation of IPA symbols using ASCII that was developed at ARPA. Rachel, sounds like DARPA. Yeah, sure does. They are related. So that's one way that you could get around it. But yeah. Also, usually those older systems used a dictionary as well, right? So like, you go from the acoustics to sounds, you have a dictionary of like, these sounds make up this word, you rank your candidates, and then you pick among those ranks using your language model. I don't think I actually said that part. If you have a pronouncing dictionary, that's a great starting point. That's not true. Alexi says, my motivation is if your language doesn't have an ASR/NLP model, it doesn't exist. Absolutely false. The lack of attention from language technologists in no way correlates to the value of a language. I definitely see how it could make day-to-day life more difficult if the assumption is that you have access to language tools that you do not have. But yeah. It makes me very sad that that's something that you've internalized, and I hope that I'm delighted that you're choosing to work on your language, and I hope that you know that the quality of any systems you produce are not a reflection of the language itself. Anyway, so that's helpful to know. Yep. So I'd say that if you are looking to create a very large data set of language data for ASR applications, you're going to hit diminishing returns after 13,000 and if hours of speech based on this sort of very lossy model. I would guess if they had higher quality data, the diminishing returns would happen much later, but that's just my intuition. And yeah, if you're in the situation of here it is. This is the one. I was like, this is about model size. This is about the data set size. Yeah, so I would say, if you're interested in creating your own data set and you happen to have access to 13,000 hours of transcribed speech, which is a lot, maybe that's as far as you need to go, because this is a big change in size and cost for not that big an improvement in performance. Which, you know what? I'm really happy they did the data ablation experiment. I would say this is probably one of my favorite bits of the paper because I think it's very helpful. I think it's good that they shared it, so good job. I do think it sort of calls into question the utility of their main, or I guess even the rationale of their main contribution, which is this data set that's not available and that we don't know what's in. And if they were, as they were collecting the data set, doing this sort of sampling, which I would actually recommend if you're working in the field and trying to figure out if you need more data, like train a small model and see how it's doing on the data you have. And if they were doing that as they were collecting data, like I personally would have stopped here, right? If I doubled the amount of data I had and got a 2%, reduction in word error rate, I'd be like, all right, there's something else that we can do that's probably going to be more effective, like cleaning up the transcriptions, or something else. But I don't know. Again, that's me. And I've never been the sort of person who really enjoys chasing, state of the art and making numbers go down as much as possible. And I realize that I am probably in the minority of people working in machine learning in that way, which is okay. That's just me and my bias and my interests. And, at this point, I would be like, I am done with this project. I I don't think collecting more data right now is the best choice. What I would probably do at that point is be like, hey, maybe we should do some different stuff with our, text standardization, and that's actually probably where we can get some bigger gains rather than adding more data. But that would also be more work for the researchers than scaling existing data collection. So Andre says, no one makes to say more than in the International Phonetic Alphabet. I love the International Phonetic Alphabet. It's a tool that I've used a lot in my life and will continue to use a lot in my life. I do not think that it is necessary to have it memorized to work on language data, but it's, again, I'm a fan of it. You don't have to be, and it's okay if you're not. I'm not, I'm not going to evangelize the good word of the IPA. Alexi says, data is internal, languages are not. Buddy, data ain't internal either. If you ever want to, give yourself feelings of impermanence and discomfort, talk to some archivists about how long data lasts, particularly data on disks. And yep. All right. That's about all I have to say on this paper. If you are interested in using it, they open source the models, which I guess is good, so that you don't need to do yourself. It may or may not be helpful for what you're doing. They certainly have the good and useful contribution of pointing out where the diminishing returns are for sort of weakly labeled, I would call it, data, or sort of low quality scraped data for ASR, which is good, right? I don't think we had like a number for that previously. I think it's a really helpful example of the sort of effect of language families and relationships on multilingual systems, right? It's a very... Which one? It's the ones with the blue swipes, this one, right? So, if you have a lot of very closely related languages that use the same writing system, you can get a benefit from creating a multilingual system. If you have not very super related languages, you're not going to get that, which is, although they are also looking at, this is blue, so it wouldn't matter, but particularly for the word error rate, they were looking at character level error rates, which I think is not usually how people working on those language families do that, but word identification and word boundary detection in CGK, Chinese, Japanese, and Korean, and related languages is non-trivial. So I can understand why they did it. And also, if you're working with a lot of language data, maybe talk to a linguist. Maybe talk to a linguist, and if you're like, hey, I recognize that we don't have linguistic knowledge on our team as we are working on this language project, perhaps if you had that linguistic knowledge in the form of someone who focuses on languages, you would have an easier time of it. And, for all of y'all, I'm happy to serve as a... to the capacity that I can, serve as a bouncing board if you have questions about sort of linguists and language technology, and that's why I have a YouTube channel and a Twitch channel, so we can talk about this stuff. So overall, frustrating paper for the reasons that I talked about. Again, it is a preprint. It hasn't undergone peer review. I mean, I guess I just peer reviewed it. I don't have anything to say about their model architecture. I kind of don't care that much, to be perfectly honest. And to be fair, like, the contribution of the paper is this large data set, and, well, that's what they wrote the paper about, some of it. I hesitate to call it a contribution because the data set isn't available and we have very limited information about it. But lots of nice examples and things that I'm sure I'll refer to in the future. I think the choral error rates in particular are like, hey, by the way, there's still some pretty big problems in how well your system is dealing with, sociolinguistic variation. And just as an aside, African-American language varieties are, internally consistent, are very predictable. Just like any other language variety, it's not like, oh, this language variety is hard to predict and difficult to do NLP on. It is not. You just have to consider it, right? Just like I'm sure that there's Arabic dialects that, within the performance on this Arabic data set are worse or better, depending on sort of how represented they were in the original training data. But anyway, chat says, maybe talk to a linguist. Rachel's having. Indeed. All right, so that's all I have for you today. I hope this was interesting and informative. I know it was mostly my opinions and me being frustrated, but unfortunately, I feel like that often happens with me in OpenAI research in the NLP domain or the speech domain, NLP and speech. Just FYI, if you weren't aware of this, historically at least, NLP has been on text, speech technology has been on speech, and they don't always talk to each other as communities. So speech people will tend to be more in like signal processing, electrical engineering. NLP people tend to be more in the computer science side of things. It's just a historical division between the fields. So it's a little bit rare to find somebody who works on both NLP and speech. Not super rare, but like a little bit rare. So anyway. So that was Robust Speech Recognition via Large-Scale Weak Supervision by Radford et al., unpublished, published by Blog Post 2022. And we will, thank you, Brett. I'm glad my insights were appreciated. We will be back on Thursday for our coffee chat. And I asked about it. Somebody actually asked about it on YouTube. I don't remember who. I can go look up the comment later. They wondered if it could be a podcast and through an RSS feed. And I think I've got it set up right. So I'll share those links. So it should now be podcastable. If you would prefer, obviously it won't be live, but if you prefer to listen to it via podcast, that should be available soon. I'm still waiting to hear back from iTunes and Spotify, but there should be an RSS feed and I'll share all those links. So if you are a podcast person, that's coming up. And I will try to be better about making sure that I, voice dictate what I'm looking at, which is also just good for accessibility in general. So, that'll be on Thursday, and then next Tuesday, I might have a special surprise for you. I don't think we're actually going to be live, but I think it will be worth it, and you will love it. So, very, very excited for next Tuesday. Assuming everything goes according to plan, knock on wood. All right. Thank you very much for joining today, everybody. Before we head out, I want to spend a second to say thank you to my wonderful coffee supporters. I really appreciate you. You help make this possible. I'm not paying myself yet, but I am also not like paying to work, which is great. And I very much appreciate it. And it's because of y'all, which again, thank you. And if you're interested in supporting me, my coffee, it's ko-fi is RCTATMAN. And if you are a monthly supporter, I send you all the links that we talk about on Thursday every week. And I think I have a few spots left of the monthly Chit Chat Club, which is where we get on a video call and just talk about language technology and stuff once a month, and that's pretty fun as well. So thank you for supporting those of you who supported me. Otherwise, thank you for watching. I appreciate you being here. I'll be back on Thursday for the new podcastable version of our coffee chat, and I'll see you then. So stay safe, stay healthy, and I'll talk to you soon. Bye.